All right, let's look at an example of a reflection in 3D. All right, so here's the matrix: 0, -1, 0, -1, 0, 0, 0, 0, 1. All right, is it really a reflection? All right, so let's find its determinant. So determinant of M, all right, is all right, 0, -1, 0, -1, 0, 0, 0, 0, 1. All right, I'm going to maybe expand along the last row. All right, so it's a 0 times anything 0 minus 0 times anything 0 plus 1 times. All right, and the submatrix would be, all right, we have 0, -1, -1, 0. So it's going to be 0 times 0 minus -1 times -1. So this is going to be -1, right? Which tells you that it's going to be a reflection. All right, so we got the reflection. All right, so we want to know the plane of reflection. So you have a plane in three-dimensional space. It's going to be reflected over to the other side of the plane. So what will be the equation of that plane? So we are looking for the plane of reflection. All right, so in order to describe the plane of reflection, you need to know the normal vector. All right, so what's special? What happens to the normal vector if you apply this reflection? So since everything is sent over to the other side of the plane, the normal vector, if you have a normal vector, if you apply this reflection, it's going to be the negative of the original normal vector. So it gets negated. So we look for that, right? So normal vector, so we want, if you apply m to the normal vector, you want to get the negative of the normal vector, right? All right, so let's try to find that. So here's the, in this particular case, we have a 0, -1, 0, -1, 0, 0, 0, 0, 1. Then you apply to this normal vector, which we don't know yet, so we're going to call it x, y, z. And we want this to be the negative of all this. So it's a negative x, negative y, negative z. All right? So let's multiply it out. So we're going to get what this times that is negative y. This times that gives you negative x. This times that gives you z, right? And this has to be equal to the negative of the original vector. So negative x, negative y, negative z. All right, so it looks like a negative x has to equal to negative y, so x and y has to be the same. And second equation actually says the same thing. But third one, since z equals negative z, what does that mean? So there are only two equations we can get. So x and y are the same, right? All right, z has to be equal to negative z, which means that you can add z to both sides. So you have a 2z has to be equal to 0, right? And if you divide through by 2, you know that the z has to be actually 0. All right, so the normal vector, so therefore, the normal vector is going to be, all right, so what was the rule? We know that the x and y has to be the same, so I would just give 1 and 1, and the z must be 0, right? So we have the normal vector. So if you want to find the plane of reflection, all you have to do is, did you guys remember so normal vector is, say A, B, C or something like that. and then it goes through a point R0. Say I'm going to put the x0, y0, z0. Then equation of the plane is a times x minus x0 plus b times y minus y0 plus c times z minus z0 equals 0, right? So that's the equation of a plane. All right, so in this case, A is 1, B is 1, C is 0, and this plane of reflection go through the origin, so x0, y0, z0 all 0. All right, so therefore we have the equation for the plane of reflection. A is 1, x0 is 0, so it's going to be x. B is 1, y0 is 0, so just plus y. And C is 0, so that's it. So is equal to 0. Right? So this is the equation of the plane of reflection. Right? X plus y equals 0. Right? That's it. I hope that this was clear.